Yellowstone National Park is situated over a supervolcano that is capable of an eruption of a magnitude of 8. The VEI of 8 is the highest level we know as mankind. It has had 3 massive eruptions, all of which have created calderas. The first eruption occurred some 2.1 million years ago, and the second one took place about 800,000 years later. Yellowstone caldera is the youngest of 3 calderas and is also the largest. Its notable features include Yellowstone Lake, the northern portion of which is located in this caldera's southeastern area. The West Thumb, which was formed by a relatively small eruption, is a knob-like protrusion on the lake's western side. 2 resurgent magma domes, one just north of and the other just west of Yellowstone Lake, have been forming in the caldera, and the western dome underlies many of the park's best known hydrothermal features. Hi, I'm Callie Bridges, and we are here in Yellowstone National Park. We're here today to talk to you about what hot springs are and the major types of soil you can find while visiting this great park. In these springs, this constant cycle creates rings of distinct temperatures around the center. Water at the center of the spring can bubble up to 101 feet from underground chambers. The temperature of these waters reaches up to around 200 degrees Fahrenheit. With water being so hot, the only life able to sustain these springs is microorganisms. I cannot talk today. Holy fuck. Water at the center of the spring can bubble up to 101 feet from underground chambers. The temperatures of these waters can reach up to around 200 degrees Fahrenheit. With the water being so hot, the only life able to sustain in these springs is microorganisms that feed off inorganic chemicals such as hydrogen gas. The further from the springs you get, the colors of the rings change as the water cools. This shows the differences in the temperatures and also in the diversity of the bacteria and organisms that are flourishing at each temperature. The area around these springs is virtually void of any trees or any kind of shade. There's no escaping the sun, and at this high elevation that Yellowstone's at, the ultraviolet light from the sun's rays become extremely harmful, not only to the tourists, but also to the organisms living. The most common type of soil you'll find here in Yellowstone is collivium soil. It's made up of loose deposits of sharp-edged rock debris accumulated through the action of gravity at the base of any cliffs or slopes. Because of their large aerial extent, temperate region soils encompass a broad array of parent materials ranging from residuum to glacially derived sediments to loess, alluvium, and collivium. Although this broad array exists, a few generalities can be observed. Hot springs formed when heated water emerges through cracks of the Earth's surface. Unlike geysers, which have obstructions near the surfaces which causes their eruptions, water from hot springs flows unobstructed, creating a non-stop cycle of hot water rising, cooling, and falling. In the colder parts of temperate regions, particularly in the northern hemisphere, a significant proportion of parent materials were derived either directly or indirectly from processes associated with late Quaternary glaciation. Many of these soil landscapes formed on glacial drifts. Extraglacial areas near glacial margins were strongly affected in periglacial processes and may have experienced extensive wind erosion or fluvial. Still other landscapes, often far removed from the glacial margins, were blanketed to thick to thin loess deposit derived mainly from ravine sediments, sources associated with wastage of continental ice sheets. Landscapes formed on recent glacial sediments have deranged drainage networks with numerous closed depressions and poor internal drainage. Not only have I learned something new about Yellowstone National Park, but we hope you have too, and hope you'll look more into what is in the ground that you're walking on when visiting parks as great as these.